Hello, Dr. Ram Ramanathan. This is Radha Gupta here. Hope you are able to hear me, sir.
Hello, how are you?
Yeah, I'm good, sir. How are you? I should say good afternoon or good morning.
It's good morning. It's 9 o'clock
Very
in the
good
morning.
morning to you, sir. Very good
Yeah.
morning to you.
Yeah.
Hope you are doing good.
Yeah, we're doing fine. No problems at all.
Okay. It's really our pleasure to have you, sir, here.
Welcome.
Yeah.
And how is the meeting going? Is it?
Yeah. Conference, huh?
Yeah, conference is going fine.
Yeah,
We
it's
had
going
good
on fine,
meeting.
sir.
Okay.
Yeah. We started in the morning with the inaugural session, followed by a keynote speaker by Dr. Kusumdeep from IIT Roorkee. And then we have Mr. Kadri from Cisco System and plenary session from Mr. Kadri. And then we had parallel tracks, 4 tracks were running parallelly. And just now we are done with all the tracks, and now we are joining you for your session, sir. Your plenary session.
Nice to know. Some of my colleagues wanted to attend this.
100% they can attend, sir.
Yeah, but I don't know what exactly is the link. I did find a QR code in the initial PDF document that you showed here. So I sent it to them. So I don't know. Is that the
one?
one?
Your WhatsApp number, I have shared the link, sir. Same link. If you forward, they can join, sir.
Oh, is it? Okay. I will do
in your
that.
WhatsApp,
Thank you.
I have forwarded a link.
Yes, I saw it in the morning today. Yeah. Thank you.
Same link can be shared, sir.
Okay, sure.
Can we begin the session, sir?
Yeah, I'll just forward this to people.
Just
okay.
Okay.
Yeah. I'll just send an email to my colleagues and then immediately start.
No problem.
Yes, I've done it. Thank you.
Thank you so much, sir.
Yeah.
Vindhya madam.
Sure. Very good afternoon to all. Thank you for joining back again. We have as a second plenary session today our distinguished speaker, Professor Ramakrishna Ramanathan from University of Bedfordshire Business School, United Kingdom. He is talking on a very interesting topic here, discovering potentials of artificial intelligence in fighting against food waste. Very apt topic for the day, I would say. So I would request Dr. Radha Gupta to introduce the speaker. Over to you, ma'am.
Yeah. Thank you, Dr. Vindhya. Thanks a lot. Good afternoon, one and all present here. And it's my privilege and honor to introduce Professor Rama Ramanathan from University of Bedfordshire, UK. Professor Ram Ramanathan is the Director of Business and Management Research Institute in the Business School of the University of Bedfordshire, Luton, UK. In the past, he has worked and taught in a number of countries, including UK, Finland, the Netherlands, Oman, and India. His research interests include the use of big data, Internet of Things, and blockchain technologies for productivity improvement in enterprises and also for the social causes. Dr. Ramanathan has successfully completed more than 30 research projects across the world. His current research projects as principal investigator includes the REAM IT project funded by Interreg Northwest Europe aimed at using big data and IoT technologies for reducing food waste in the agribusiness supply chain. And the other project is the TAF project funded by the Newton Fund for improving productivity of artisanal fishing in Brazil using IoT sensors. In addition, Dr. Ramanath is on the editorial boards of several journals and in the technical and advisory committees of several international conferences in this field. He has produced 5 books, more than 130 research publications in journals, and more than 170 conference presentations. I would also like to share the abstract what Sir has sent about his presentation. The application domains of artificial intelligence are ever increasing. Availability of huge amounts of data, machine-to-machine communications, cloud storage, blockchain, and emergence of newer methods of data analytics have helped to kindle renewed interest in artificial intelligence developments. Some experiences from a large European project will be used in his talk to discover exciting possibilities of using artificial intelligence to identify causes, patterns, and solutions to the food wastage crisis. That would be really good, sir. It is a common knowledge that significant quantities of food produced gets wasted due to various reasons. Nearly 1/3 or nearly 13 crore tons of food gets wasted in the world. In India, nearly 40% of the food valued at rupees 92,000 crores gets wasted every year. The European project uses Internet of Things sensors to sense food quality. The data from these sensors are then analyzed using AI technologies. His talk is going to uncover some promising potentials of using AI techniques with sensor data. A very apt topic, sir, and I'm sure students are really going to like it. Not only students, even we are all going to enjoy and learn a lot how we can actually not waste food. So how it can be prevented. Thank you very much, sir. Over to you for the talk.
Thank you. Thanks for the kind introduction. As the title indicates, I'm trying to highlight some of the potential benefits of artificial intelligence in our research project that Professor Gupta has mentioned. First of all, thanks to Professor Gupta, organizers, other organizers, and Professor Mathirajan for inviting me to this talk. I'm a mechanical engineer, but over the last maybe about 15, 20 years, I have been working in business schools. So I have built up a bit of a reputation in terms of making business sense of many of the technologies being used in engineering. In the same way, the talk today is going to be focused on the potential applications of AI. I'm not an expert in AI, but I know what are the potentials of AI and how it can be used in improving businesses. So I have a team of people who are experts in the techniques of artificial intelligence. So I don't boast of any significant knowledge, but I've been a very avid researcher on operations research in or modeling. So I know somewhat about modeling. I have a number of papers on that. But the new ideas of artificial intelligence are provide some exciting possibilities, and I usually leave it to the hands of my teammates, younger teammates who are experts in those areas. Well, I consider my job to be more a business specialist who try to make use of all available technological improvements and innovations for the benefit of businesses and for the benefit of the society. This is the initial position with which I want to start this talk. Then this is going to be my main outline for this talk. I'll talk briefly about artificial intelligence. As I highlighted, I don't boast significant knowledge in artificial intelligence, though I know what it can offer and what it cannot offer. And I will review some of the previous applications in the food industry. Then I'll explain why we have chosen the topic of food waste and explain why focusing on it is going to be very, very important at this present juncture. Professor Radha Gupta has already highlighted from my abstract that there is significant quantities of food being wasted through the world, including India. So if we can do even a very little bit of effort to save maybe even 1% of food waste, it is going to make huge difference to the livelihood of several inhabitants on Earth. Then I will talk about the role of digital technologies, the new big data, Internet of Things technologies, etc., in reducing food waste, and then introduce the research project that I am leading currently in Europe. I will also talk about what are the demonstration activities that we are currently carrying out, and then outline some of the exciting possibilities that I'm really confident of achieving in the next 2 years. Our project has started about 1 year back, and now we are in the process of fitting sensors in several parts of Europe, and we have started collecting data. And obviously, data analytics will take a little more time, maybe about 6 more months. And when we have a steady stream of data coming on food quality in various parts of Europe, we will start analyzing it. And one strategy of analysis is going to be the use of artificial intelligence. I'll just outline what we hope to achieve. And I'll also have some questions and answers. Before I go to the next slide, what is the total time available for this presentation, Professor Gupta?
Sir, you can take 50 to 60 minutes, sir.
Okay, then. Okay, thank you. I don't need to explain much about the the idea of artificial intelligence to this audience here, because the conference itself is about the applications of AI and computational mathematics. The Encyclopedia Britannica defines artificial intelligence as the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings, that is us, human beings. It emerged as the field in the 1950s when people were talking about the operations research modeling. And it actually gained prominence in the 1990s with the emergence of expert systems. Then it is actually gaining a second phase of recognition right now, thanks to the great improvements in computing power and analysis power. And going by the first earlier definition, I would now like to think that the definition is somewhat outdated, because now we think artificial intelligence goes much beyond the comparison with intelligent beings, in the sense that we human beings cannot even think about handling such volume of data that present day computers are storing and analyzing. So it's impossible for a human being to keep track of so much of data and then make sense of all of them, whereas artificial intelligence with the present computing power can potentially bring out real good patterns and good insights that even human beings cannot do. So I would think that the previous definition of artificial intelligence is somewhat outdated, and it should be replaced by the ability of present-day computers in collecting, storing enormous amount of data and identifying patterns and creating intelligence. And the emerging ideas of big data, Internet of Things sensors, cloud, blockchain, robots, drones, artificial intelligence, machine learning, etc., hold promise to revolutionize the supply chain. Some of the applications in the past in the food industry of artificial intelligence include intelligent harvesting. Even now, there are new technologies being brought out that help robots to do image processing and pattern recognition, decide which crop is good, ripe enough to harvest, which crop is not ripe to harvest, and then picking up the right kind of fruits and vegetables from the farms. There are also other examples like carrot topping, root removal, apple picking, etc. Then you have a whole range of artificial intelligence robot-based robots talking about picking, packing, in quality control, in trying to find out which food is good enough to eat, which food is good enough not to eat, but for going to animal feed, and which food is not at all fit for any kind of consumption. Maybe it should go to anaerobic digestion and those kind of things. And there are intelligent machines now that look at sorting and grading, removing contaminations in food particles. So huge amount of effort and improvements have taken place in the field of applications of AI in the food industry. I'm sure that several of us know much more than the list, but these are some examples of techniques that people use in when they say artificial intelligence. It's the combination of more than one modeling effort that is going to provide additional knowledge, additional intelligence about the thing being investigated. Starting from artificial neural networks, convolutional neural network, predictive analytic fields, computer vision, regression, fuzzy logic, expert system, principal component analysis, and so on. There are so many new and conventional techniques that are available that together form the umbrella of artificial intelligence and help us make better decisions with the huge amount of data that we encounter nowadays. Specifically in the field of food quality, because we are talking about, in our research project, we are talking about identifying food quality and then trying to find out means to make use of food before it becomes food waste. So it's important that we look at some applications of artificial intelligence in locating food quality. There are a number of papers that talk about how artificial intelligence is being used in managing food quality. I've just used one of the recent publicly available papers to tell you potential possibilities. Now, in terms of food quality, artificial intelligence has been used for food recognition, classification. If you have a series of carrots, for example, which you can sort the like-sized carrots and so that they can be packed separately. Food calorie estimation, quality detection of vegetables if there is an apparent issue on the surface of food that can be easily detected. Quality detection of fruits, quality detection of meat and aquatic products, food supply chain and food contamination. Some of the detection of fruits and vegetables, meat and aquatic products also include the use of volatile organic compound sensors that sense the gases coming out of food products and decide whether the product, decide the stage of ripeness in which the product is. So if it is too ripe, then we can say that the probability that the product becomes waste is very, in the next few hours, is very, very high. If the product hasn't reached its the maximum ripe position stage, then probably we can think that the product has more life to go. So we have a lot of information that goes into detecting quality of fruits, vegetables, meat, and aquatic products. Some examples of the use of AI in detection of quality of fruits and vegetables are given here. For example, fruit recognition in smart refrigerators. Now, when you place food in your refrigerator, there is image processing mechanisms and probably some special sensors, volatile organic compound sensors, or maybe more, that keep track of the quality of produce kept within the refrigerator and then provide you alert that this product is likely to become waste. So there are people who have used this particular idea and used artificial intelligence for this purpose. Prediction of firmness of pears, detection of artificially ripened banana. This has been one of the biggest problems in the banana industry. You don't want banana to be artificially ripened, but people do, and you have now artificial intelligence techniques to detect it. Mangosteen surface defect detection, plum varieties classification. There are many such examples. I've given you only a few. And it appears, I'm sure that people would have used a number of techniques, artificial intelligence techniques, and apparently nowadays we reach classification accuracy as high as 90, 95, 97%. Now, let me move back to the research project that I'm talking about, which is a project on reducing food waste. So we want to reduce food waste. Before that, we want to tell you why reducing food waste is important. Food waste is a global problem. As Professor Radha Gupta has already highlighted, 1.3 billion tons of food is wasted in the world every year. 40% of food in America and again 40% of food in India are wasted, and 20% of the food we buy never gets eaten. That's why smart fridges are more important. We keep buying and putting them in the fridge and discover at a later stage that we really forgot. Hello? Okay. Food waste is a global problem, but the patterns of food waste in India, though nearly 40% of food is wasted in America as well as in India, the patterns of food waste in India is a lot different to the pattern of food waste in America. In the US and in almost all developed parts of the world, food waste, majority of food waste occurs at the consumer side. We have a huge amount of purchasing power. We buy more than what we need, put it in the fridge or store it somewhere at our house and forget and throw it away. In most European countries and in America, this is the pattern of it. The highest level of waste occurs at the household level. Whereas in developing parts of the world, including India, more waste occurs at the production and distribution level. It's because of lack of storage, good storage for the product and transportation for the product. But both in developed and developing world, the transportation or the supply chain is equally important. Now, there's a significant quantity of food waste occurs at the supply chain. And you can see in the graphic, seafood is wasted nearly up to 50%, fruits and vegetables 48%, grains 38%, milk 20%, and so on. And if we try our level best to reduce even a very small proportion of this amount of food waste, then we will be doing a lot of benefit to the society, to the world, to the economic development. And our project focuses on how we can we can exploit the power of new digital technologies, including Industry 4.0 ideas, big data, Internet of Things, business analytics, to help reduce food waste. It's not that ours is the first to talk about how to use technology to reduce food waste. There are a number of examples already tried and tested in the world on using technologies for reducing food waste. But the very first point here is very important. Food waste saved is much more than the value of food of the waste. Suppose we throw away maybe 200 kilograms of banana or 200 kilograms of apple from a supermarket because it wasn't sold before the product was deemed a waste. Probably the cost of those apples would be maybe around 2,000 rupees. Not much. But the amount of efforts, resources that went into producing those apples are huge. For example, it is estimated that to produce one apple, you need at least 80 liters of water. And add to it huge amount of human effort, fertilizer, energy, etc., that went into producing those apples. If you look at all the items that went into producing those apples, then actually the value of the wasted apple is much more. It's not the real market value, but it's the real value that of whatever went into producing the product. So food waste saved is much more than the value of the waste, and it has huge social and environmental benefits. Environmental benefits because if 200 kilograms of apple becomes a waste, it emits lots of methane, which is a greenhouse gas that affects the atmosphere and affects climate change. It goes to landfill. It adds to the existing strain on landfill. So lots of environmental issues. And it also has social issues. Now, while we throw away a huge amount of money, huge amount of waste, there are a significant part of the people in the society who are hungry. So if instead of wasting it, if we can somehow redistribute it to those who need it, it has a lot of social implications. So food waste saved has a lot of social and environmental benefits. Smart sensors can keep track of freshness of food, including temperature, order, etc. in fridge. Now I'm coming to the headline, which is digital technologies. How can digital technologies help in reducing waste? RFID tags increase transparency of the entire supply chains. With RFID and blockchain, you can trace where the product is coming from. The entire supply chain can become very, very transparent. For supermarkets, sensors can support decisions on whether to sell at discount, donate to charity, or send to landfill. Sensors will decide on food quality, help make these kind of critical decisions. Sensors and smart fridges can help people buy exactly what they want, avoiding overstocking of products. In an ideal scenario, if I'm traveling, if I'm going to a supermarket trying to pick up something, I should get an alert from my smartphone saying that your smart fridge mentions that this product is already there in your fridge. You don't need this product. Okay, so it is not an ideal possibility. It is already in vogue in some parts of the world. Smart garbage bins, smart waste management systems, smart garbage trucks can, when I say smart, it is a sensor that is wirelessly able to communicate what is happening inside the truck, inside the bin, that can help us make decisions. So you can see in almost all the technology applications that I highlighted, artificial intelligence is at the core. And the REAMIT project is basically created and motivated by these kinds of applications on the use of digital technologies for helping to reduce food waste. So I have been talking about the REAMIT project, but what exactly we mean by REAMIT? REAMIT stands for improving resources efficiency of agribusiness supply chains by minimizing waste using Internet of Things sensors. It is a project funded by the Interreg Northwest Europe. It's a funding body that manages funding in Northwestern Europe. The University of Bedfordshire Business School is the leading partner. I'm the lead. And we have a series of 16 partners that are part of the consortium. This includes a number of universities, but also includes firms like Levstone, Wiser, IT Trally, Senex, Valorial, Action Sense, etc., who are specialists in business analytics and artificial intelligence. So we have a group of people who are experts in managing food, managing food waste, and also analysis in understanding what is happening. There are people who are experts in the choice of sensors, in the use of sensor technologies too. The project is worth 4.8 million euro. It started in 2019 and it will be ending in 2022. It spans 5 different countries across Northwest Europe. It includes the United Kingdom, it includes Ireland, it includes France, Germany, and the Netherlands. The idea is simple. In the REMIT project, as the title has indicated, the focus is more on the supply chain, in reducing food waste in the supply chain, because about 1/3 of food waste occurs when the product moves from the farm to the supermarket along the supply chain. So ideally speaking, somebody produces fresh food. It may be apples or oranges, or it may be strawberries, it may be meat, it may be fish, anything. And there are people who are intended customers. It may be supermarkets, or it may be final consumers if you're using online systems. And obviously, there is always a huge distance between where the product is produced and where the product is needed. So you need a supply chain system to transport the product from the place where it is produced in various trucks or trains or even flights, and sometimes stored in between in warehouses before being transported to in different trucks and so on. So there is a lot of supply chain process going on in between. And what happens is that people, if somebody ships, say 100 kilograms of apple, the estimate is that by the time it reaches the intended supermarket or customer, only 65 kilograms of apple becomes good. The remaining 35 kilograms gets wasted somewhere in the supply chain, because nobody knows what is going on in the supply chain so far. So what we plan to do is that we try to install sensors in trucks and warehouses. We are not focusing on trains or planes at the moment. In trucks and warehouses where the product is stored or transported, and make the sensors speak. Sensors measure something and then send the information to the cloud. So we have big data platforms, smartphone apps to collect the data and do analysis. And if we find that there is a chance that the product in a particular part of the truck or a particular part of the warehouse is likely to become bad because the temperature control system is not working well enough, then we try to provide fast information to owners saying that there is a likelihood that the product will become waste before it reaches the intended customers. Instead, we give them some suggestions. We call it as decision support system, some suggestion as to how the product can be made use of before it becomes waste. So we tell them there is a group of nearest customers available with whom you can engage in talk and identify where to dispose of. Or it may be that if the product is too bad, then we can tell that it's not worth selling. It may be worth sending it to food charity for immediate use and supply to the needy. In case the product is not fit for human consumption, then we may suggest animal feed production and so on. So all sorts of possibilities we can provide. This is what we call decision support systems. So in Reamit, sensors will monitor and record food quality along the supply chain. We use traditional sensors, temperature, humidity, light, vibration, ambience, and so on. New sensors like volatile organic compound or carbon dioxide emission sensors, and more novel technologies like Raman spectroscopy or 3D fluorescence that actually captures the amount of gas that are coming out from the product and make a very accurate prediction of the level of ripeness that the product is currently. Waste reduction is achieved by supporting owners at risk using big data analytics, artificial intelligence, and decision support systems. Food owners, truck drivers, warehouse managers will be connected using a dedicated smartphone app. That is the way we communicate back to the food owners. Right now, our technologies, which is basically a technology that installs sensors and connects them to the cloud and collecting the data in the cloud and for data analytics, is currently being installed in 5 different countries in multiple locations. Some of the examples are here. We have an online supermarket in the Netherlands who are partnering with us, and we have fit sensors in their supply chain system in the supermarket delivery vans, and try to find out whether the products are being sent in the right condition from their storing warehouse to the final delivery to customers' families' houses. We have a fresh food, ready to eat or frozen producer company in France. We have a beef producer company in the UK, online food distributor company in Germany, and fresh vegetable producer company in Ireland, and more companies are expected to join in the next few months. A little more information about each of the pilot tests. We call them as technology demonstrations or pilot tests. They are the same. So the Dutch pilot test involves a Dutch online supermarket. It is a new generation supermarket that works only online. It's like Amazon that works only online. So customers make order using smartphones or online computer systems, and product is shipped from their fulfillment center to the homes of customers through dedicated electric delivery vans. And this van has a lot of compartments. Each compartment is meant for different kind of products. Now they are color coded. Some compartments are coded to make sure that only ambient groceries are kept in. Some items do not need refrigeration, like for example rice, wheat, and so on. So ambient conditions. Some of them require refrigeration, storing between 2 to -2 degrees. So maybe milk, some vegetables, and so on. And some of them require frozen, chilled on -8 degrees, for example, -8 to -20 degrees. So there are multiple compartments in the van that stores different products at different temperatures, and sensors are fitted in all the compartments, and the information about how the product is being kept is sent to the centralized server, which we host in the University of Bedfordshire. So we will look at the personalized cooling profile per cooling box, check the outside weather conditions and the temperature required inside, and how effective our cooling technologies are in maintaining the temperature, required kind of temperature. We also link the data from sensors to customer compliance. I'll come back to it a bit later. So we have different crates going into truck. There may be ambient, chilled, or frozen, different categories. And within a question of 1.5 to 2 hours, we will collect everything from the hub, from our warehouse, to the end consumption point, to the houses of customers. So within this period, we track everything that is going on in the truck. So we have a lot of sensors inside the truck. They are linked to the cloud using LoRaWAN system. The data is collected in remit.wiser.com and ultimately go to our big data server. We link from online weather data and look at the various combinations of food in the box and look at various complaints from customers as to what is how they received products, then make sense of any improvement needed in the transportation system. The second one, the German pilot, is a complete online delivery supermarket. It's also similar to the Dutch one, but in contrast to the Dutch, we are talking about complete overview of what is happening in the in the transportation product. Unlike the Dutch one, which started probably somewhere in here, now after the product is moving from warehouse to the companies, the delivery company's warehouse, only a small part of the supply chain is focused, whereas the German pilot talks about looking at everything right from the grower to the intermediate storage, transportation, and then from fulfillment center to final supermarket. So we are looking at everything along the supply chain to make sure that the product is transported at all points in time in the right temperature, humidity, and other required one. We have smartphone communication system for all parts of the supply chain to make sure that everybody knows what is happening with the food. It's similar to the Dutch pilot. We also have the sensors, GPS sensors, VOC sensors, etc., connected to the remit.wiser.com. Wiser is one of our partners, their cloud, which will go to our big data hub within the University of Bedfordshire. We'll link it to online weather data, customer compliance, and inputs from employee at different stages, including the images using cameras and other text-based systems. And all those information goes into this the cloud system for analysis. And in the UK, we have a slightly different pilot test. We have two different pilot tests. One is to detect the presence of bacteria on meat surface and prioritize this meat if needed. So what happens is that meat is produced and stored, but some meat may be prone to a kind of bacterial attack and develop certain amount of bacteria, which needs to be detected. If we fail to detect it, then most likely the meat will become waste within a matter of a few hours. So early detection is important. We use technologies like 3D fluorescence technology. This fresh detect sensor is a 3D fluorescence technology. If you keep it close to the food, it picks up the bacteria and their signatures and then tells what kind of bacteria and how much time is left in the quality of the food, with the meat. So we use this to provide the early detection warning to the company that there is a problem or not a problem with the meat. The second one is to detect quality and weight loss of food in dry aging chambers. You know, this kind of dry aging chambers that with lots of hot and humid air is used to dry the meat, and some meats lose water fast and some meats don't lose water fast. So we want to detect the quality of the meat during the processing in the dry aging chambers. So there are many more, but I'll stop with discussing these three. The impact of the project: in the next few months, we'll calculate carbon emissions avoided by reduced food waste using VMI technologies. What we do is to try to avoid food becoming waste. So we calculate amount of food waste that we are avoiding, and then convert it into equivalent carbon dioxide emissions. As we have seen, if we save food waste, it helps avoid wastage of equivalent amount of resources, water or energy or human effort and so on. So we can combine all these things into a single measure of carbon dioxide emissions. Ultimately, we want to save about 1.8 million tons of food waste, or 3 billion tons of 3 billion euro worth food waste per year in Europe, which would be equivalent to avoiding about 5.5 million tons of carbon dioxide in emissions in Europe. Okay, now let me focus a little bit more on typical AI applications. It's about 30-35 minutes, so I'll spend about 10 minutes on the potentials of artificial intelligence. As you can gather, we haven't come to the stage yet where we collect data and then use the data for modeling and so on. So we hope we will be able to come to this stage in the next 6 months. We have just started collecting data, but what in the next few slides, I'm trying to give my own vision of how we plan to use artificial intelligence. My partners who are experts in this area will do a better job, but my job is to make sure that they follow the overall idea of how to use artificial intelligence in reducing food waste. Typical AI applications, it could be data mining, clustering of potential food banks, neural networks, workflow automation, fuzzy logic, evolutionary optimization, etc. Now, for example, when we say optimizing food route networks for large-scale alternative routing of food to be avoided. I told you, we are fitting sensors inside trucks. They may be traveling somewhere along the corridor, along its route. And maybe at one point in time, we will detect there is a potential quality loss. Maybe a temperature control system is not working. When we detect it, it may be somewhere in the middle of its travel. And our job is to provide immediate warning. So we will have built some rapid decision-making systems. Our algorithms will detect quality loss, collect the data, and regularly update and analyze. And it will detect quality loss, and immediately it will trigger an alert that will go to the truck driver and also to the food owner, saying that there is a problem. Then we will also look at what happens with the food. What could we do with the food because it is stranded somewhere in the middle of its journey? We look at what is happening. Are there any potential buyers surrounding the area within 5 miles of, for example, where the truck is currently? And we collect data about their availabilities, their interest, and then pass on that to the owner and the truck drivers. And we will also collect data on food banks if that is needed and tell them. And finally, once the owner decides where to dispose it of, we will have to find the shortest possible distance route to that particular demand point, which we do using automated algorithms. So optimizing food route networks is very important here. For food quality monitoring and control based on the big data, main areas of AI include data processing, analysis, and decision support using deep learning techniques. Big data analytics identify patterns of food waste in Northwest Europe. NWE stands for Northwest Europe, for supporting suitable policy actions. What happens is, because we have a lot of data, we will start collecting data on where our trucks are going, where our warehouses are located, where historically, when we have built up maybe 6 to 8 months of data, we will know historically what are the corridors, what are the areas, what are the roads where there is a potential quality loss. We will have to identify why certain roads certain areas are more prone to quality loss compared to others, and find out the reasons and drivers behind it, and help government to make amends to the causes of food waste, and then try to maximize the benefit of not wasting. So in the long run, we will also try to identify patterns of food waste. We'll use artificial intelligence, as I highlighted, to as a decision to provide decision support to food owners for making rapid decisions, including redistribution, optimization of food delivery points, increased food shelf life using real-time cold chain monitoring. A small example here, I just talked about our Dutch pilot. I told you from their fulfillment center, where the warehouse where the product is stored, electric trucks take the products to customer homes. And the truck has multiple compartments. By measuring things like temperature and humidity inside the cool box and outside weather conditions, we use artificial intelligence to predict the amount of cool packs that have to be added to each cool box, regarding weather forecast and the duration of the time the cool box is inside the truck. So we need to use artificial intelligence to give us a reasonable understanding of how much of cool packs we need to put inside each box to make sure that the temperature is at the right level by the time it reaches the customers' homes. So this is how we can set a personalized cooling profile. Obviously, this personalized cooling profile depends upon each trip. Every time we decide what to put inside the cool box, the amount of cool pack that we need to make sure that the temperature is kept at the right condition is will be different. So every time we need to do the analysis. And more important and more interesting idea is we measure shock detection of the cool box. We have a kind of a sensor that tracks the amount of shock that the cool box is subjected to. Obviously, the truck is going along the road, and the road can have bumpy, potholes and whatever. So there is a potential possibility that some products get affected because of vibration. For example, eggs can get broken. So what happens is that we use the data from the sensors. We will have sensors that measure, that track the vibration of these boxes. And we use the data from the sensors. And we also look at the road along which the product has traveled, and look at how much of complaints received from customers. If too many eggs are broken, obviously the customer is not going to be happy. It will lodge a complaint. Then we can try to combine all of them to find out, is there a pattern that we should avoid in delivering eggs and other products that are sensitive to shocks. So this is how we will be using artificial intelligence in our analysis. There are many more interesting opportunities for using artificial intelligence. I'm not going to spend too much time on these things. Development of optimization, shortest path algorithms for locating the nearest demand point is a modeling work. Multi-criteria models for matching food at the risk of becoming waste zone to the best nearby customers, which will not only maximize its revenue, but also increases the chance of utilizing the food effectively. And this is an interesting model that we are currently developing in deciding the optimal rerouting of a truck based upon several conditions, which appears somewhat similar to standard optimization problem, but it is not. It is more complicated. We need meta-heuristics and probably more artificial intelligence techniques. New and innovative pattern recognition techniques. We hope we'll be able to use artificial intelligence to decide the pattern recognition options, identifying food at risk and associated legal issues, decision support models for rapid redistribution, estimation of increased food shelf life due to real-time cold chain monitoring, analytic game theoretic models to show motivations of insurance companies to engage in bargaining for goods that are monitored and controlled. The interesting possibility is that if we have a truck that has better visibility of what is happening along inside the truck, then the insurance cost of transporting can come down because insurance companies will be more confident that the product will be kept in good condition. So we can have a kind of a bargaining model that talks about how much of technology should we put inside a truck that minimizes the total cost of insurance and the technology installation cost. There may be more. I'm going to stop here, and I think I've almost taken 50 minutes. So I'm going to stop here. There are many more possibilities. Thanks to my colleagues for their help in producing these pictures. Now I'm happy to take questions. Thank you.
Thank you, Professor Ramanathan, for the wonderful session. It was definitely an important application with respect to AI and IoT for that matter, and the other allied techniques that you talked about. So thanks again for sharing this interesting project that you and your team are working on. Hopefully, we get to see, get an opportunity to see the experimental results that you are expecting to be out in the coming days. Any queries from the audience will be entertained at this juncture. Audience participants, if you have any queries, kindly let us know through either the chat box or directly unmuting yourselves. Any questions from the audience? Somebody in the chat box has probably sent a Mr. PG Bhatt, who is again a distinguished speaker for tomorrow's session, is here with us, and he has mentioned that it was a very informative talk. Thank you, sir. Thank you, Bhatt, sir, for giving these inputs. So anybody else, any queries from the participants?
I suppose because I haven't talked about the real artificial intelligence techniques, maybe some of your, most of your audience are more interested in the techniques rather than the business view. But I think it's a combination of the development of individual techniques along with making sense of how to use those techniques for business purposes. That's more important. So my job is more about the second part, making sense of what are the potentials of artificial intelligence rather than working on artificial intelligence as such. So I'm sure in the next few months, we will start working on real data and analytic techniques. And hopefully we'll have better, more detailed, specific applications.
There is one question.
More conversations, yeah.
Radha, please.
There is one question in the chat box, again by Mr. PG Bhatt. Any information on the computing infrastructure that you can share, sir?
Yes, we have a big data system that that has, I mean, I cannot, I'm not technology person to be able to give you full detail about what I said was I had my partners in computer science, experts in computing. They suggest a very high spec big data system. I can send the details about the big data system, but it is it has huge storage because we are talking about a lot of data coming on real time. When I say real time, at least every 30 minutes, we will collect data on the characteristics of food from different sensors. Some of the sensors that we have talked about, the Raman spectroscopy, some of you may be already knowing about that technology, are the 3D fluorescence. They are highly specialized sensors. when you say temperature, if I fit a temperature sensor, it sends out temperature measurement every 30 minutes. That's not big. It sends 1 byte of information. Whereas this Raman spectroscopy sends a few megabytes of information every 30 minutes. And the 3D fluorescence sends out a few megabyte of information. It is a spectral information of whatever gases are emitted from the produce. So kind of think of storing that information every 30 minutes continuously for 3 years. Huge amount of data storage is needed, and we are building huge data storage and also huge amount of computing power to be able to make use of them in real-time analytics. But unfortunately, I'm not technical enough to give you the specifications, but I can share that information. This will be available online in the project website. If you look at www.reemit.eu, we have a very up-to-date web page that gives all specifications. At the moment, our website does not provide the data on the technical specifications, but it will be available soon, because I think this month we expect our big data server to be online, to be able to link to all the data that are produced in various parts of the Northwest Europe. So if I don't know who was who asked about this one, I will be able to share this information to whoever is interested offline, because I cannot give that information right now. I'm not a technical person to give that information. I can ask my colleagues to do that.
Okay.
Thank you.
So indeed, that was a very, very good presentation, very good talk, and actually an eye opener, because when we waste something as food, no, we don't even realize that we are contributing to the 92,000 crores worth of food that we are wasting. So a real good eye opener for all of us. Lot of things to learn, whether we do research in this or not, but there are so many things which we should know. Learn from this. A lot of takeaway key points from your presentation. Thank you so much.
In fact, I also wanted to highlight that we are keen to work on similar projects in India. You know, what we do in Europe is good, but as I highlighted, in India also there's a big problem of food waste in the supply chain, and in a limited sense, whatever we do in Europe is also applicable to India. So we are keen to have partners who will be working on producing some proposals of similar kind.
Oh, that's good, sir. That's wonderful. Probably we may look for some opportunity to work with you.
Yeah. Thank you.
Yeah. Thank you. Any closing remarks, Dr. Vindhya?
Yes, ma'am. So thank you, sir, once again. That brings us to the end of day one of the 3-day sessions. I thank you all for your participation and interaction. We will start day 2 tomorrow morning at 9:15 a.m. sharp. There will be a keynote session by Ms. Nimisha Sharat Sharma. She's a data and applied scientist at Microsoft Seattle, USA. She will be talking on deep learning models in production, a study on personalized recommendation systems. I hope to see you all there tomorrow morning at 9:15 a.m. The talk will start sharp at 9:30. So I request you all to kindly join the session tomorrow. The link has been shared with you all already for day 2 session 1 keynote session. So kindly use the link to join us. Thank you all. Have a great day ahead. Bye.
Thank you very much.
Thank you so much, sir. Thank you.
Your organization. Bye-bye. Thank you.
Thank you, sir.